simplifying algebraic expressions. And what is an algebraic expression? We've been kind of working with them throughout this chapter. Remember, algebraic meaning that we're going to have some variable in our expression, and our expression is just something that doesn't have an equal sign in it. So when we're talking about algebraic expressions, we're talking about something like 3x plus 5. There's an algebraic expression. I could write that in a different way. I could say this 3x plus 5 is x plus 2x plus 3 plus 2. So there's another algebraic expression, but it has the variable parts that we can add together and the plain numbers that we can add together. Now, these are called constant terms. Constant because there's no variable by them. They always stay. 3 is always 3. 2 is always 2. But 2x changes depending on what your value of x is. So these are our variable terms, and these are our constant terms. So in this section, they will give you some things to add together. Like this always gets students. 4y plus y. Should be 4y, right? No, I see a head shake. No. What should it be?
It should be 5y, right?
5y. It should be 5y. Why? Because there's a y there.
Because, yeah.
There's one y there.
Not 4yy.
Not
5yy.
Right. So we have 4y and 1y. And if I really wanted to think about this, what does 4y mean? 4y means that I have 4 y's. And 1y means that I have another y. So how many y's do I have there? 5y. So the thing that you need to keep in mind when we're doing these problems is if you see a variable, there's really a 1 in front of it. Now, we've been looking at properties of expressions or properties of mathematics, where we talked about commutative, we talked about associative, we talked about distributive. And the distributive one was normally we had a number out in front of the parentheses that we distributed out over each of the terms. Well, another way to think of this problem is to say that we have a y here that's in both terms. That's in common. So that y was distributed out over both terms, and those two terms were a 4 and a 1. Now we have the 4 and the 1, and we can simplify that down to 5y. So we're really using the distributive property here when we're simplifying things down. To make things more complicated, because we're never satisfied by just keeping things simple, right? I'm a math teacher at least, so I gotta make things complicated. We have 7x minus 2. So we have a variable term, a constant term, we have a variable term, and a constant term. I'm going to want to switch this around so that my variable terms are together. So when I'm switching the order that I'm writing things, what's that called? You got it. You guys are so smart.
Commutative.
It's the commutative step. So we have the commutative step that we're performing right there. Now we're going to perform the distributive step. And we're going to pull that x out of these two terms. And we're going to get 7 minus 7 and minus 2 plus 6. 7 minus 7 is, because those are inverses of each other, it's the additive inverse. So we now have this. And what happens with 0 times anything? That's the 0 property of multiplication. And then now we're just left with numbers, and we can add a -2 and a +6 together to get +4. That's a lot of steps, isn't it? But it's the official proof of simplifying this expression down, this original expression down to what it equals. And it's all of the different steps that in our mind we've already gone through, but we don't necessarily have to show them. We don't have to list them out and label them. Sometimes they ask you to do that. I'm not going to ask you to do that. I might ask you, what step did I use here to go from this to this? I won't ask you to start here and get down to here and put all of these steps in the order that they should be. So I just wanted to state that right out. I'm not going to be that mean to you to have to do that. But I do want you to know what those different properties are. Okay. Oh, I'm going to ask this. How would you guys approach simplifying this down?
We would put the constant values with the constant and the variables with the variable.
So you're telling me you would rewrite it?
Yep.
Like that. Can I have a show of hands as to who would do that on their paper?
Well, I wouldn't just know it right away. I'd have to, organize my thoughts to figure it out.
Okay.
I wouldn't do that immediately. Yeah.
Okay. I probably wouldn't do that either. What I would do, but if you're comfortable doing that and that makes sense to you, go ahead and do that. I'm just going to write the problem over here to show you what I would do. I would say, oh, I have a y term, and I would circle it. And I would go across and say, oh, here's another y term. I'm going to circle that, and I'm going to circle the sign out in front of it also. Is there any other y term there? No. So what is 9 minus 11? It's a -2. And because those both have y's there, I'm going to put a y down next to it. So -2y. Then I'll go to the constant term. I have a -4. Where else do I have a constant term? Right there. -4 plus 7 is how much? +3. That's what I would do rather than doing this. The part that you guys have to make sure that you do and this is going to be the tricky part for you, is to always remember to take the sign out in front of the number with that number. So it was a -4 plus 7 to get that +3. So keep the signs out in front and use those when you are adding like things together. So for this problem, +6n, +6n, -7n. +6 and -7 give me a -1. And then I have a +1n. So a -1n and a +1n, I end up with 0. So those all cancel out. What else am I left with here? That all simplifies down to -4. Does that make sense? Okay, so if you're doing it this way, I would like to see some kind of way that you're gathering all of the like terms together, whether it's circles around the like terms or whether it's moving them around so that they're all right next to each other. Either way, just show me some way that you're doing like terms together. On page 391, there's some other terms that they talk about that they want you to identify. These numbers out in front of the variables, those are the coefficients. It's the official name for them. And it's just the number part out in front. So in this example here, the coefficients would be 6, -7, and +1. The coefficients are the numbers out in front of the variables. We already talked about constant terms, like terms. I think we've pretty much covered everything from that section. So, page 391, 1 through 14, and 20 through 31. Questions?